Welcome to solverfy.
We are given a generating function, and we are asked to provide a closed formula for the sequence the generating function determines. In part A, we are given the generating function 3x minus 4 cubed determine the sequence that this generating function determines. Multiply this out, and so this is equal to 3x minus 4 times, although we could use the binomial theorem here. If we use binomial theorem, we get this is equal to 3 choose 0 is 1, 3x cubed, and plus, and this is 3 choose 1, which is 3 times 3x squared times negative 4 to the first, plus 3 choose 2, which is also 3 times 3 to the x to the first times negative 4th to the second. Finally, plus 3 choose 3 is 1 times negative 4 to the third. This is equal to, we have negative 4 to the third power is negative 64, and then we have 9x and 4 squared is 16, so plus 9 times 16 is 90 plus 54 is 144x. And then we have 3 times 9 times negative 4 is 27 times negative 4, which is negative 80 minus 28, which is negative 108x squared, plus 3 cubed is 27x cubed. And so we have the sequence arising from this generating function is sequence with terms a0 equals negative 64, a1 equals 144, a2 equals negative 108, a3 is equal to 27, and an is equal to 0 for all n equal to 4, 5, 6, and so on. In part B, we're given the generating function x cubed plus 1 cubed using binomial theorem, we have that this is equal to x cubed cubed plus 3 choose 2 is 3, x cubed squared times 1 plus 3 choose 2 is 3, x cubed, and plus 3 choose 3 is 1 times 1. And this is equal to 1 plus 3x cubed plus 3 times x to the 6th power plus x to the 9th power. And so the sequence corresponding to this generating function is one with terms a0 equals 1, a1 equals 0. Maybe a simpler way to write this. a0 equals 1, a3 equals 3, a6 equals 3, and a9 equals 1, and we have that an is equal to 0, n is equal to 2, 4, 5, 7, 8, 10, 11, 12, and so on. In part C, you're given the generating function 1 over 1 minus 5x. By a theorem, we have that this is equal to 1 plus negative 5x plus negative 5x squared, and so on. And this is going to be equal to 1 minus 5x plus 25x minus, and so on. And we have that the sequence corresponding to this generating equation is one with a0 equals 1, a1 equals negative 5, and actually in general we have that an is going to be equal to negative 5 to the n for all n equal to 0, 1, 2, and so on. In part D, well, instead of a negative 5x, this should just be a positive 5x here. So this is positive 5, this is simply 5, so this is 5 to the n. Now in part D, we're given the generating equation x cubed over 1 plus 3x. This is equal to x cubed times, by a theorem, we have that this is going to be 1, and this is minus negative 3x, so 1 plus negative 3x plus negative 3x squared plus, and so on, and this is equal to x cubed minus 3x to the 4th plus 9x to the 5th minus, and so on. And we have that the sequence corresponding to this generating function is 1 with a0 equal to a1 equal to a2 equal to 0, and an equal to negative 3 to the n minus 3 for all n equal to 3, 4, 5, and so on. In part E, we're given the generating function x squared plus 3x plus 7 plus 1 over 1 minus x squared we have this is equal to, by a theorem, x squared plus 3x plus 7 plus 1 plus x squared plus x squared squared plus x squared cubed, and so on. and this is going to be equal to, we have 1 plus 7 is 8, plus 3x, plus 1 plus 1x squared, which is 2x squared, plus x to the 4th, plus x to the 6th, and so on. And so the sequence corresponding to this generating function is a sub 0 equals 8, a sub 1 equals 3, a sub 2 equals 2, and you have that a sub n is equal to 0 if how should I state this? N is odd and n is greater than 1. And we have that a sub n is equal to 1 if n is even and n is greater than 2. In part F, we are given the generating function x to the 4th over 1 minus x to the 4th minus x cubed minus x squared minus x minus 1 and we have that by a theorem this generating function is equal to x to the 4th times 1 plus x to the 4th plus x to the 4th squared plus x to the 4th cubed, and so on, minus x cubed minus x squared minus x minus 1. And this is going to be equal to negative 1 minus x squared minus x cubed and plus x to the 4th plus x to the 8th plus x to the, and this 2 times 4 is 8 plus 4 is 12 plus x to the 16th and so on. And so the sequence corresponding to this generating function is a0 equals negative 1, in fact, to abbreviate this, we have that a0 is equal to a1 is equal to a2 is equal to a3 is equal to negative 1. And then we have that a sub n is equal to 1 if n divides 4, or not n divides 4, but 4 divides n. And we have that a sub n is equal to 0 otherwise. And in part G, we are given the generating function x squared over 1 minus x squared. We have, by the table in the book, this is going to be x squared times 1 over 1 minus x squared is 1 plus 2x plus 3x squared, and so on. So this is equal to x squared plus 2x cubed plus 3x to the fourth, and so on. And so we have that the sequence corresponding to this generating function is one with a sub 0 equals a sub 1 equals 0, and we have that a sub n is equal to n minus 1 for n equal to 2, 3, 4, and so on. And finally, in part h, we're given the generating function 2e to the 2x. We have that by the table in the book, this is equal to 2 times 1 plus 2x over 1 plus 2x squared over 2 factorial plus 2x cubed over 3 factorial, and so on. And this is equal to 2 plus 4x plus, and this is going to be 2 cubed, which is 8x squared over 2 factorial plus, and then 2 to the fourth is 16 over 3 factorial x cubed, and so on. And so we have that the sequence corresponding to this generating function is a sub n is equal to 2 to the n plus 1 over n factorial for all n equals to 0, 1, 2, and so on.